Welcome back. As promised, in the second video we're going to dive deep into the strategy and design of our tanks. At the beginning of every season, teams are given a playing field full of missions to solve in less than 2.5 minutes. In order to solve the missions, teams need to build a robot made out of Lego Mindstorms.
The first step we take is to group together the missions that are close to each other and can be easily solved with the same tools. As a result, the field is subdivided into smaller zones. Some of the missions have to be solved in a specific order to attain the maximum score. Some of them even obstruct the way to other missions, so they have to be left out for last. The end goal is to establish the most efficient path for the robot to complete all the missions inside the time limit.
This allows us to customize the tanks for each launch and design simpler mechanisms and tools. The shape of the tanks is just as important as the route they follow. The core doesn't have a fixed frame, so the structure of the tanks can be easily adapted to the demands of the terrain.
For the first example, bridges. These structures have the shape of an inverted U and ride along the wall, avoiding obstacles and moving way faster. This is usually more reliable, that's why we try to use bridges as often as possible. A variation of these are mother tanks. The robot itself is very small, but it can push a large structure, complete missions, and then leave it behind and continue on its own.
All terrain tanks are needed when obstacles can't possibly be avoided. These tanks have to be prepared to go over obstacles, that's why they need more grip and stability. More grip just means more wheels.
Sometimes the robot has to go under an obstacle. With our standard interface, the robot is too tall, so we have to design another structure where the core can fit horizontally, lowering the profile.
Sometimes, the rules require us to hang the robot from a mission model. In order to do this, we have to design a robot with two very strong arms, which can lift the entire weight of the robot using very powerful gear radios. You may wonder how the robot makes its way around the table. We'll explain this in the next episode.